All right, welcome back. In part 2 of this video series, we calculated the integral of 1 over x squared minus 1 by using trig substitution. And we got this kind of slightly intimidating expression down here involving some square roots and some natural logs. And today, in part 3, I'm going to calculate the same integral, but I'm going to use a different method. And so we're going to integrate 1 over x squared minus 1 by using partial fractions. And so the idea here is that we want to split it up as a sum of two integrals over nicer functions. And so we want to find a and b so that this equation is true. And so let's solve the algebra for a and b. Okay. So what we want is we want to be able to do 1 over x squared minus 1. We want that to be equal to a over x minus 1 plus b over x plus 1. And so if I get a common denominator on both sides, well, then if I do that here, it's going to be a x plus 1 plus b times x minus 1. And I'm just going to get 1 on the other side. Right. So what must be true is that these two numerators, which I can mark in red, must be equal. Right. So what I have is an equation that says 1 has to be equal to a times x plus 1 plus b times x minus 1, no matter what x is. Right? So this is really supposed to be true no matter what value of x is. Right? And so we're going to solve this, and I just want to kind of put the answer here straight away. So the answer is going to be that a is equal to 1/2 and b is equal to minus 1/2. How could we solve that? I actually want to show two different ways to solve this. So method 1, this is a method I recommend. So method 1, we sort of equate coefficients. And so on the left-hand side, we have 0x plus 1. And on the right, we have ax plus a plus bx minus b. And if I rewrite that, I get 0x plus 1 equals a plus bx plus a minus b. So what we have is we have an x term on both sides, and we have a constant term on both sides, and those have to be equal. So we can set those equal. We get 0 equals a plus b, 1 equals a minus b, and then we can solve that system. For example, I might add these two equations together. If I add them together, I'll get 1 equals 2 times a equals 1/2. And then I can use the second equation to see that a minus b equals 1. So I would see that b equals negative 1/2. Right? So I actually recommend just pausing the video and just solving the system yourself, right? Because you probably have your favorite way of solving systems of equations. Sometimes I like to use substitution. Sometimes I like to do this combination method that I just did. But I'd really recommend you solve that system. Right? So now let's do method 2. So we have our same equation, so let's write it again. 1 equals a times x plus 1 plus b times x minus 1. Maybe you like method 2 a little bit better. So method 2 is going to be say, well, I know this equation has to be true no matter what x is. And so I could just try some different values of x. So for instance, if I let x equal 1, then I could plug that equation and I get 1 equals a times 2 plus b times 0, and then that immediately tells me that a has to be 1/2. And then that's really great. And so now I could now try a different value. So now I rewrite my equation. A equals 1/2 times x plus 1 plus b times x minus 1. I still don't know what b is, but I could now try a different value of x. Maybe I could let x equal, I don't know, 7. And then if I try that, I'd get 1 equals 1/2 times 8 plus b times 6. And once the dust settles, I'd get, let's see, this is going to be a 4. So I subtract from 1, I get negative 3 equals 6b. And that's going to mean that b equals negative 1/2. Okay. So we got the same answers, and this method will work. You can just try any values of x you want. I find this method a little bit more confusing for students because it's maybe not clear why we can let x be different things. So that's why I did method 1 first, where we solve that system by equating coefficients. So that's really the way I'd recommend solving it. But in any case, we're almost done. Let's finish this problem. Let's go all the way back. So we have this integral here. Let's copy. So I have an integral, and we're going to copy that, and we're going to paste that down here. And I'm now going to substitute in what we found a and b to be. So we know that a is going to be 1/2, and b is going to be negative 1/2. And so now I can carry out that integral. That should be 1/2 times the integral of this expression. I missed a minus sign. And so this is going to be 1/2 times the natural log of x minus 1 minus 1/2 the natural log of x plus 1 plus c. Okay. And so that's a nice expression. I think we did this in class. And now what I want to just finish with our very last page is I want to sort of point out we've done two things. So in video 2, we showed that this integral was equal to something. And in part 3, we showed that this integral was equal to something. So let's just copy sort of what we have here. So if I copy this, put it right there, right? So I've got this expression, and if I go back in my notes and I see what did I do in part 2, what was the answer there? Well, it's something a little bit different. It's this expression here. Let's put it side by side. And at the moment, they don't really look the same. One has a square root, there's some coefficients, there's a minus sign. And so I want to just do as our final check, I just want to check that these are the same. And so what I want to do is I want to simplify this expression, negative log of x plus 1 over the square root of 1 minus x squared. And I just want to convince you that it's going to equal this expression down here. Right, and this is a good chance to review some of the log properties. And so the log properties that we're going to use, maybe I'll do those in red. We're going to use that the log of a fraction, so a over b, is log of a minus log of b. And we're also going to use that a times the log of b is the log of b to the a. So let's see these in action. Let's switch back to green. So I'm going to get negative log of, let's just keep the minus sign in front. So I'm going to get log of x plus 1 minus the log of square root of 1 minus x squared. Right, so there I just use that first rule to write that as a difference. Then I'm going to, may as well distribute this minus sign, so I get negative log of x plus 1 plus the log of, I'm going to rewrite this. I'm going to actually rewrite this as 1 minus x squared to the 1/2 power. Okay. And now what I'm going to do is I'm going to bring that 1/2 in front. So now I have 1 minus x squared. And then I'm going to do one last thing. I'm going to factor this expression. So I'm going to get log of 1 minus x times 1 plus x. And I'm going to use one last log property that I forgot to write in here, and that's the log of a times b is the log of a plus the log of b. And so when I do that, I'm going to get negative log. Okay, I'm going to rewrite the first term. This is going to be 1/2 times log of the first term plus log of the second term, 1 plus x. And I'm almost there. And now I'm just going to notice that I have two like terms. I have a negative 1 and a positive 1/2 of these. And so when I combine those, I think I'm going to get, well, let's rewrite this middle term. That's 1/2 log of 1 minus x. And then these other two terms here are going to combine to give me negative, they're going to combine to give me negative 1/2 log of x plus 1. And now we look back and we, let's see if I can do it with a highlight. If we look back at our, well, maybe I'll do it in a different color. Let's highlight this in blue. If we look back at our thing we wanted, it was supposed to be 1/2 the log of x minus 1 minus 1/2 the log of x plus 1. I see exactly the second term down here. And in the first term, it looks exactly right, except instead of an x minus 1, I get a 1 minus x. But since I'm taking absolute value, the absolute value of 1 minus x is the same as the absolute value of x minus 1. Okay? And so we really do get the same expression. And so this is a longer video. Thanks for sticking with it until the end. We got a chance to review some log rules. If there are things in here where you think you have extra questions or you want extra practice, leave a comment, send me an email. Thanks for watching. Bye.